Hello, grade 10 math students. It's great to be talking to you. So we're officially on week 3 of this remote learning project or journey that we're going on. And like I said in my overview video, we're switching things up a little bit where you'll have access to all of the materials from day 1. So here is the first lesson. We're going to talk about linear systems. So a linear system in grade 10 math essentially is going to have 2 linear equations. And remember, a linear equation looks like something like y equals mx plus b, okay? And when we find the answers at the end, so you need to find, the goal is to find x and y, to find x. And when we find those, that's actually a coordinate system for a point. And to solve these systems, it's where, if we were to graph these things, where these 2 equations, these 2 lines, cross or intersect. Okay, so that's that point of intersection. And that's the solution to the system. So if we were to graph these 2 lines that are here, y equals x plus 2 and y equals negative 2x plus 5, then they're going to cross right here at this point of intersection. So the point of intersection here is actually at x is 1, so 1. And y looks like 3. Okay, so my point of intersection here is 1 and 3. And we've done a lot of graphing, so I really just didn't feel like we needed to review it again. And plus, graphing is like the least efficient way of solving a system of equations. It takes forever. We have to plot it out, we have to draw 2 lines, we have to see if they cross, and you could be graphing on and on and on until you find if the 2 lines cross. So we can actually check by substituting the coordinates into both of the equations. So if I were to look at this, I know from my point of intersection here that x is my first one, y is my second one. So that's telling me that I have an x value of 1 and a y value of 3. So let's check this. So if I put y equals x plus 2, and for my x, if I have 1 plus 2, that's going to equal 3. And now let's try this again, and I know that's right, so that should be 3. So let's try my next equation, y equals negative 2x plus 5, and I'm getting these equations just from up here, okay? And so instead of an x, let's replace it with a 1. Negative 2 plus 5, well, that's 3. Okay, and they're both the same at that point, and they both equal what y should equal, so this is good. This means that this works. Math smiley face. We got the same number. Awesome. Math magic. Okay. So let's scroll down a little bit. Let's actually look at this question. So 2 online music providers are offering special music memberships. Citrus Wire charges a monthly fee of $20 plus $1 for each song. Earbud charges $10 monthly, but $2 per song. So this isn't like, you get Spotify Premium and now you can download everything. This is back in the olden days when we would do this sort of thing. And so we're going to let N represent the number of songs and C represent the total cost per month, okay? So if I were to graph these, and I already did it for you, but if I were to graph them, let's talk about this for a second. So the first one, I have one line that's going like this. Obviously not using a ruler because I'm a rebel. And one line that's going like this. Okay? And where these cross, okay, that's my point of intersection. This actually, point of intersection, this is my break-even point. So this means that up until this point, I'm going to spend the same amount of money. Okay, so at this point, I'm spending the same amount of money on both services. So remember that we said that N was, what did we say N was? N was the number of songs, so this is number of songs. They did a crappy job of labeling these axes. And C is the total cost. Okay, so let's explain this a little bit. If I am looking at this graph and I'm downloading 10 songs or less, okay, it's actually cheaper for me to go with the dotted line. At 10 songs or less, it's going to be less expensive for me to use the dotted line, because if I'm looking at here, this is hitting less on my cost. But as soon as I download more than 10 songs, now it's going to be cheaper for me to use the solid line. Okay, so I could be at $45 and I would actually get 30 songs instead of spending $45 for like 18 songs. Okay, so that's what this graph is kind of talking about. So if you download less than 10 songs, then we want to choose our earbud service. If you download more than 10 songs, then now you want to use Citrus Wire. Okay. So then if you were to download only 10 songs, let's just go to the scenario where we're only downloading 10 songs here, then it doesn't matter which company you're going to choose because they're both going to cost the exact same. So it's going to be $30 for either company. And again, I'm getting all of this information from this graph on the right-hand side, okay? The point of intersection for this graph, I just realized I forgot to answer it up here, is 10 and 30. And what that point means is that when you buy 10 songs, the cost is exactly the same between both companies. Okay. So let's talk about our points of intersection a little bit. So when we are finding our points of intersection, this is also called the solution. So these are some other words that we could see for point of intersection. The solution, as well as the break-even point. Okay, so those are the two ways that we can kind of describe point of intersection. All right, so let's talk about solving them a different way. So that's the way that we talked about up here, this is solving a system by graphing. Okay, so this is solving because I physically had to draw the graph for each of them to find the solution. Now let's talk about solving by substitution. So let's just say I have these two equations. I have y equals x, negative x minus 6, and y equals 3x plus 10, and this is a negative sign. Okay. The first step of solving by substitution is that we want to make sure that at least one equation looks like a y equals equation or an x equals equation. Sorry, my voice cracked there because I sneezed, but I paused so you didn't have to hear me sneezing. Okay, so we either want one of the equations to look like y equals or x equals, and if I'm looking at the ones that I have given here, both of them look like y equals, so that's great. Both equations are in this form here, and what this means is that this equation is saying that y equals negative x subtract 6, and then this equation below it is also saying y equals 3x plus 10. And if they're going to be equal at the same point, then we can actually end up substituting the first equation in for y. And remember, substitution means replace. So in one of the equations, we're going to replace y with negative x minus 6. Okay? So let's do that in the next step. So I'm going to label this equation 1, equation 2, and I'm going to substitute 1 into 2. Okay, so I'm going to have negative x subtract 6 because it was y equals. So instead of the y, I've just put in negative x subtract 6 equals 3x plus 10. Okay, so again, this used to be y. Okay? So now I'm going to solve. So I have this equation, negative x subtract 6 equals 3x plus 10. And the first step that I'm going to take to solving this equation goes back to our videos last week. I'm going to pick the side that has the most amount of x's on it. So if I'm looking at the left-hand side, I have negative 1x. If I'm looking at the right-hand side, I have 3 x's. Negative 1 is smaller than 3. So I want all of my x's to be on this side of the equation. Okay, and I'm going to do that by using opposite operations to move things back and forth between the equal sign. So if it's a negative x on this side, I'm going to add x to get rid of it. If I add x to the left-hand side, I have to add it to the right-hand side. Okay, so this is what I've changed here. Oops, sorry. Undo. This is what I've changed here in this step. Okay. And right here. So now, let's simplify. Negative x plus x, that just leaves me with negative 6 on this side. 3x plus 1x, that's going to be 4x's plus 10. And I want x to be by itself on the right-hand side of the equation. So I'm going to look at this and I say, what's happening here with this 10? Well, I'm adding 10 on the right-hand side. To get rid of adding, I'm going to subtract. So I'm going to subtract 10 from both sides of the equation. This 10 minus 10, that's going to go to 0. I'm going to go a little bit into the next box. And leave me with 4x here. And then negative 6 minus 10 is negative 16. And then once again, what's happening between this 4 and this x? So again, negative 6 subtract 10 is negative 16. You can use a calculator to get that. And what's happening between this 4 and this x? Well, that's multiplication. What's the opposite of multiplication? We're going to divide. So I'm going to divide by that 4, and I have to do it to both sides. 4 divided by 4 leaves me with x, and negative 16 divided by 4 is negative 4. So what does this mean? This means that when both equations are equal to each other, my x point of that point of intersection is going to be negative 4. Okay. So my next step is I want to take the value that I found, so this negative 4 for x, and I'm going to substitute it into any of the equations that I had. So you can pick 1 or 2. I think 2 is going to be easier because there's no negatives in that. So let's just rewrite equation 2. So I'm going to sub x equals negative 4 into my equation 2. And again, remember that substitution just means that I'm replacing. So I'm telling you that I'm replacing x in my second equation with negative 4. So every time I see an x, I'm just going to write a negative 4. 3 times negative 4, that's going to be negative 12 plus 10. Negative 12 plus 10, that leaves me with negative 2. So what this means here is that you're always going to get a solution as a point of intersection. So I'm going to get this solution. It's going to be a point of intersection. So I need to write it as a point of intersection. So my point of intersection, or my POI, is going to be my x first, then my y, just like the alphabet. So it's going to be negative 4, negative 2. Okay? And I'm going to check to see that this is right. So I check to see that my POI is right by substituting the value back into my equation. So I'm going to take my x value. I'm going to make this a little bit bigger so that we can look at this. I'm going to sub x equals negative 4 into my equation. So on my right-hand side, and y equals negative 2. So if I have my equation here and it's y equals negative x subtract 6, I'm going to put my y into my left-hand side. So my left-hand side just had a y. So instead of a y now, that's going to be negative 2. Okay. My right-hand side in that equation was negative x subtract 6. So instead of an x, I'm going to replace that with a negative 4. And notice here that the sign that's in front of the letter still stays outside the bracket. That's why we use brackets when we substitute. So that negative 4 gets put in its own bracket, minus 6. And if I'm looking at this, this is why we do that. We have to be very careful with our signs. A negative and a negative are going to make a positive. So -1 times -4 is actually +4 minus 6. And 4 minus 6, that's going to equal -2. And I know that this solution is correct because here I have -2 and here I have -2. So my numbers match. My left side equals my right side. And I'm extremely happy with an excited math smiley face. So if I move on to my other equation here, which was the second one that we had, I'm going to do exactly the same thing. So I'm going to sub x equals -4 and y equals -2 into my equation. So on my left-hand side, I had y. Now I'm going to make that a -2. On my right-hand side of the equation, I have a 3x plus 10. And I'm going to replace that x with a -4 plus 10. 3 times -4 is -12. Add that 10. -12 plus 10 is -2. And once again, my left side and my right side are exactly the same. So I let us know. And very happy with an excellent math smiley face. Okay, so this is basically today's lesson. We're going to be doing a little bit more of this tomorrow as well, but I want you guys to go back and review if you need to, go back and watch the video and go back to that worksheet and do the questions that I've indicated, okay? I hope that you're having a fabulous day and I can't wait to touch base with you. Keep checking in, sending me emails, letting me know how everything's going.